Hey everybody, and welcome back to another Taiji development log. I'm Matthew Van Dievender, and Taiji is a open-world adventure puzzle-solving game that takes a lot of inspiration from The Witness. If that type of thing sounds interesting to you, there is a link in the description below to find out more. Something that's been the case for a long time on the game is that the whole map was just always active the whole time the game was running. And for the most part, this doesn't really cause performance problems. Like, if we look at a build here I set the resolution a little low because I'm trying to limit on the CPU. But I'm on a 5600X, which is a pretty modern CPU. I just updated that this week, so it wasn't quite as good before, but you can see we get 400 frames per second, right? So it's not really a big deal that everything's active. Hey, it's me from the future. That bag's still on the floor. I wanted to interject because I was thinking about that I didn't mention the reason primarily that I even did this optimization. So, although it runs really well on my computer, on somebody with much lower powered hardware, it doesn't necessarily run that well. And I had a tester who was talking about performance issues, who was running the game on, I guess, not exactly a great laptop, but so that was some motivation that I wanted the game to run better, because I think even though if you had a 10-year-old laptop, you wouldn't expect it to run Elden Ring at 60 frames per second or something. Because Taiji is sort of a two-dimensional game with pixel art, even though it's a premium two-dimensional game with, it's got bloom and it's got different effects and there's lots of procedural shader things going on, it's still people expect it to just run on whatever. So it's kind of just me trying to meet that expectation a little bit better. In an ideal world, I'd like to exceed people's expectations and for people to be really surprised at how well it runs, but I think at the limit I'm kind of hampered somewhat by that I've made the game in Unity and I can only really optimize things so much before I'm just running up against the limits of what Unity's capable of. Alright, back to the video. But one of the things that I did these past couple weeks was some performance optimizations that involved doing culling. So essentially, what culling means is that, for instance, well, actually, I can just show you. So yeah, so this is the cold scene of where we are in that same build, right? So you can see there's still a bunch of stuff that is not visible that gets drawn. Well, it doesn't really get drawn because Unity does its own culling, but it's still active, right? That's because I decided to do sort of broad phase culling in the sense that each of the areas in the game that has a hub, that will get culled if that area is not visible. Oh, okay. The yellow ones here are the ones that are visible. The circles, the circles that are overlapping with this rectangle. So this rectangle is the screen. So if I go over here, you see that that's what we can see. And these are the circles that are overlapping with it. So the way that these culling things are set up is that each area gets its own set of culling circles, or spheres really, but it's all the same. So let's just look at the plateau here, right? So the plateau is just these circles. And if I go in and I turn off the other areas, there's also some stuff that's always active. The game might break if I turn this off, but I'm going to turn it off just to show you that everything that's within this hub here fits inside of these two circles, right? That's the idea. So as long as these, well, I guess there's a little bit here maybe, but there's a little bit of fudge because you're comparing a rectangle of the camera to to these circles. Well, I think it's not even a rectangle because it has to be a square. So there's a little fudge that probably this shadow is okay that it's overlapping a little bit, but I'll keep that in mind. But generally the idea is that if this circle is not visible, then nothing in that area should be visible, right? That means that if the camera's outside here, right, we could cull that area because it's not visible. Now culling doesn't really happen based on this view, it happens based on this view. Okay, so I decided to kind of try to show you how this works as best I can. So in this view, you're going to see things get culled or not. And in this view, is just the game running, right? So you can see, like, as I move around, things are, like, coming into existence or not. Obviously, you'll notice that there's puzzle panels there that come into existence, but there's also, like, large sections of the world that get enabled or disabled. So the way that I have this set up is that for each area root in the game that might get disabled, there is a area culling component. Excuse me. If you had like thousands of these culling spheres, then you might want to do this more where you had like a manager class that kept track of all of them and kept track of which ranges applied to which thing that you want to have disabled or enabled or whatever. But because there's like not that many really, I figured it would probably be fine because in any case it was going to be faster than having Unity figure out the culling for everything. But each of these things has like the root of the thing that it culls, and it's got a list of culling spheres, and that's got a little flag here that has to do with the transition into the end game or the bonus area, which sort of happens outside of the normal like culling system. So it also has its own like separate component to handle culling just for those areas. But that's a little bit outside of the scope. So if we look at the code, essentially the way that is that I define this class of culling spheres. The reason that I define this is because the bounding spheres that Unity uses are not actually inspectable, and even setting them as serializable doesn't allow them to be inspectable, so you can't set them up like you can't just make an array and have it show up in the inspector here. I would have had to write a custom editor that did that, and rather than write a custom editor, I just decided to just do a class, and then when you do on validate, it just copies the data from one thing to the other. So on validate gets called anytime you like change something here. So like if I change this value, then it's going to update the actual bounding spheres. So bounding spheres is a Unity class that's tied into the culling system. So what we do when this gets enabled is we make a new culling group. We set its reference point to the camera essentially, and we set the bounding distance. It's to 16 here, but it's going to get adjusted to whatever the camera zoom is. So I don't know if this is a actual distance. I guess it is. So it actually makes a circle of the camera, but close enough. So we just copy those bounding spheres over and set that up, and then we tell Unity to call us back anytime that culling group either becomes visible or invisible. So then that happens down here. We get called back. And sphere will have like a property that tells us whether it's visible or not. There's some other stuff in here that had to do with the end game weirdness and fixing some bugs there. But generally speaking, if it's visible, then we want to set that root active, right? So that means if that sphere essentially overlaps with the circle that is what's visible of the camera, like it's within a certain distance, then we set that group active. As far as setting it inactive, we handle that a little bit differently. Hey, look, it's future me again. So actually the reason that we handle setting things inactive differently is because when we get a callback, one of those on state change callbacks, that's only for a single bounding sphere. So we can't actually make a decision about whether or not the area is visible just because a single bounding sphere became invisible. We need to know that all the bounding spheres became invisible. So that's essentially how that works from a technical perspective. I guess if people want the code, I could post the code up. But it's pretty standard, I think, just for dealing with that. As far as I can tell, Unity doesn't have any like automatic setup for disabling things based on culling spheres. It's really just a thing that you can get called back from, that's lighter weight than doing something like a trigger test, which I do still do a lot of trigger tests for things, but this is generally speaking faster. Mostly because you can send in an array of like thousands of spheres and it can do that really quickly. But I'm only doing a few, so it probably doesn't make much difference either way. The next thing I wanted to go into was sort of the reasoning and the methodology by which I determined that this was the thing to do. So anytime you're doing any kind of optimization, it never makes sense to go in blind. You always want to profile things. So, and in Unity, luckily has like a built-in profiler tool. You can go to Window and Analysis and Profiler, or I guess you can hit Control-7, or it might be mapped to something else. There's kind of two versions of it. There's the profiler that's, I guess, sort of the legacy profiler, and then there's like a profiler that launches a standalone process, which I don't know if it makes a big difference if you're profiling in the editor. But generally you don't want to profile in the editor anyway because you're going to get different behavior in the editor versus in a build. But if we look at our profiler, I've got it hooked up to the build that does not have culling. So I'm going to run the build here for a second, and what you're going to see here in the profiler, what you see in the profiler, and probably most profilers work this way, is you've got a timeline here, and so time's going along from left to right, and like each point along this is a frame, and the contents, I guess, of this graph are the duration of different things in that frame. So it's how long did the frame take to render, right? So then we got like some little benchmarks here, so you can see like we're above 200 FPS, which is below 5 milliseconds a frame. So if I click anywhere in here, then we're going to get a kind of chart down here, or a list of all the things that happened during that frame. There's a few different ways you can look at the list. If you want to, you can like look at it as this timeline thing, which is like kind of useful if you're trying to just like get a glance of like all the function calls for the frame and like what's the order in which they happened. I don't quite know how to get rid of this thing. This is like a new thing they added, I guess. I've never seen it before. Anyway, and then there's another couple things. The raw hierarchy can be useful in some cases, but most of the time you're just going to be looking at the regular hierarchy. So let me move myself back to the corner. So what you're going to want to do is find the single function that is using the most amount of frame time. I guess I should point out the difference between hierarchy and raw hierarchy, because it will make a little more clear what I mean by single function. So in raw hierarchy, you actually have like single function calls in the list, whereas hierarchy collapses all functions of that type or of that name will get collapsed down. So say you have like the power manager update. Well, that's not really a good thing because there's only one of those. Let's say you have like a power source update, and there's like 100 power sources in the game. If you're in hierarchy view, those 100 things are going to get collapsed down to one update thing, so you can just see what in aggregate those all took. Whereas if you're in the raw one, you're going to have 100 different instances of that. So something you're going to want to make sure is that you have this sorted by time milliseconds. So there's a couple things over here. There's self milliseconds and time milliseconds. Self milliseconds is like, it's attempting to calculate like what an individual instance of the thing takes. So it's like, I guess, spitballing based on how many there are and dividing the total cumulative amount by that. In any case, you want time milliseconds, not self milliseconds. And you want to sort that. There's a very small down arrow here. It might be hard to see on the thing. I don't know why I'm getting a pinwheel of death there, but that's popping up. But in any case, you want that to be down, because otherwise it's going to go in reverse order, which is not going to be super obvious, I guess, at the top level, but at the lower level it does matter. We want the things that are the slowest or take the most amount of milliseconds at the top of the list. So we can see that the most thing at the top here is in post late update finish frame rendering. And the biggest thing in there is camera render. So this is like a little unfortunate, right? Because the easiest thing for us to optimize, right, is to go into our scripts and just like try to optimize the script. But it's clear that our scripts are not actually taking up that much time compared to this. Like, it is taking up some time. It's like 0.28 milliseconds, which is like 280 microseconds. So it's like 280 microseconds and like 180 microseconds here. Not an insignificant amount. They're like 14% of the frame, but like 45% of the frame is in this section here, and almost all of that is in camera render. So you might think camera render is just like that's GPU or GPU bound here, but we're actually looking at the CPU profiler. There's like an additional thing for the GPU that you can turn on that's separate. If you want to look at that. But this is entirely CPU stuff related to rendering. So if we twirl that down, then we'll see that like the biggest thing here at like 20% of this section, or I think that's 20% of, it's either 20% of the frame or 20% of this section, is culling. It's actually like twice as much as drawing is culling. And if we go in there, it's just scene culling, and there's just some nonsense in here about this, right? So it's spending an awful lot of time on culling. So what is culling, right? Well, culling is essentially when you've got a lot of processing to do across like a lot of different things or whatever, and you're trying to figure out ahead of time if there's some things that you can just not process. Because essentially the fastest optimization to code, or the fastest code, is like no code at all. So if we can just not process things, it's always going to be faster than trying to make the act of processing those things faster. But of course, trying to figure out what we can and cannot exclude, I guess, from processing, that also takes processing. So culling is really only as effective as if it's faster than just doing the thing, which in this case I'm sure it is. I can't disable culling completely in Unity to see what it would be like if it had to draw the whole world always, but it's still definitely taking like 20% of the frame time. So if I can eliminate most or all of that, then that's a big win in terms of the performance. So that was the idea of creating the culling system. Hey, me from the future again. So when I said culling system here, I felt like it was a little bit confusing the way that I put things. So there's kind of two culling systems, right? So there's the Unity built-in culling system, which is just where Unity tries to figure out what's going to be on screen or not from whatever's in your scene. And then there's the culling system that I created for Taiji specifically that culls areas ahead of time, so that the culling system that Unity has, the built-in one, just doesn't have to deal with that stuff. So I'm just like trying to cut down on extra culling work by doing the lion's share of it first. I feel like that's technically wrong, lion's share, because like usually when the lion's share would be like what you left behind, so that would be like a small piece of it. But anyway, I'm doing the majority of the thing hopefully first. All right, back to the show. and the culling system just culls areas because Unity doesn't really know that it's a 2D game, that things don't move around that much, and the areas are mostly static, and if you're over here, you're not going to be able to see this because nothing from over there is going to suddenly come over here. But I know those things, so I can do that optimization myself and handle culling those things. So that's pretty much the methodology for that. That's why we ended up focusing on culling, because it was the thing that was taking up the most time. The reason that I didn't do this earlier is just because in a big game like this that's complex and has a lot of areas and a lot of different things, setting up a system that's going to, disable an area, it sort of requires that I know that area is not going to change very much. Because setting up the culling system makes the game less flexible, right? Because I got to place down all these culling spheres that exactly cover what's in that area. And if they don't, then there'll be glitches or whatever, right? So I needed to wait till the game was almost done, to where things were mostly finalized, before I could even really do this optimization. So even though it was something that I knew was a problem and I thought about years ago, that just having everything active was probably not ideal, it still made sense to leave it like that until things kind of more solidified. Okay, so I thought I would kind of end things off just with a performance comparison after the fact. This was recorded a little bit later because let me turn this down. I actually did this earlier and I had some weird VSync issue that was causing the frame time graph to have a bunch of weird spikes in it, and I have to assume it was related to recording rather than anything else. So let me get rid of this GPU usage graph. Actually, well, I guess we can look at the GPU usage graph. Oh, okay, never mind. Doesn't work in builds because I'm using jobs. But we can definitely see that I think before we were close to 500 frames or something, and now we're down here. And I think I'm actually even running at 1080p, so it probably could run even faster if I dropped it down to the same resolution that we were running at before. Let's try putting it down to 720p. Yeah, so we're pretty darn close to 1.5 milliseconds for the total frame time. And if we look in here again, I thought about this actually after doing this, that I'm sorry that the fonts are so small. I should have thought about that and set up the DPI scaling in Windows to make it bigger, but whatever. So if we look in, we definitely see that culling is still the biggest thing, right? But we can see that now culling only takes 310 microseconds or whatever. So 0.31 milliseconds. It's a significant improvement, I would say, to say the least. Anyway, that pretty much does it for this. Hopefully it was interesting or possibly entertaining in some regard. I know it's kind of dry always to do technical stuff, and I didn't do anything wacky to try to make it that much more exciting, but maybe you learned something that could be useful for your own game. It's certainly more late stage optimization stuff, but that's kind of why I threw the profiler stuff in there, so just in case somebody's not comfortable with or familiar with using a profiler, maybe they can see that it's actually not really that scary once you kind of know what you're looking at, I guess, which is impossible to tell because it's just tiny little pixels on this video. So hopefully you have a super HD monitor to look at this on. Anyway, I'm still interested in taking audience questions so that I can do these videos maybe more frequently, or once a week, I guess, which would be as frequently as I've just done this. Since I think that it's good, more is more as long as I have something to talk about, right? I feel like I was getting to a point where, because I wasn't talking about anything, less was kind of more. So I'm just trying to have like interesting topics. I'll try to think of something. This is the problem, right? I'll try to think of something before next time. I got so many other things going on. It's like, what am I even gonna talk about? But if anybody has any questions, feel free to leave a comment below about that, or if you'd like to, you can drop by the Taiji Discord group and you can ask your questions there to go in a video, and yeah, I'll be happy to look at those. Anyway, wherever you are, have a good evening, have a good afternoon, have a good night, whatever time it is. I will see you all around on the internet. Have a good one, everyone. Bye-bye.
Come here, Peaches. Peaches is here to dance for you. She doesn't like to dance. No, she doesn't.